Hello and welcome to tribetopper.com.
And you're watching Solutions to Numerical Problems on Coulomb's Law. So question says two fixed point charges 4q and 2q are separated by a distance x. Where should the third point charge q be placed so that it is in equilibrium? So let's find out the solution. So here's the diagram which represents the two charges 4q and 2q, and they are separated by a distance x as stated in the question. So this distance is x, and let us assume, they say where should the third point charge q be placed. So let's assume that we place the third charge at this point q, where it is at a distance of a from this charge 4q, that's a, and therefore the distance would be x minus a from the other charge, right? So it's x here and this would be x minus a. So how can we solve it? Now by Coulomb's law we know that the force between two charges is the product of the charges and inversely proportional to the square of distance between them. So let F1 be the force on charge Q due to the charge 4Q. So that would be Q times 4Q upon 4 pi epsilon naught R square. My R here would be A. So A square, that's equation number 1. And similarly by Coulomb's law, F2, the force on charge Q due to the other charge plus 2Q, this one, would be Q times 2Q upon 4 pi epsilon naught times R. In this case, the distance is x minus a whole square. Now, the question says for this charge Q to be in equilibrium. So, what should be the condition for the charge Q to be in equilibrium? These two equations would be equated because the force on this charge F1 in this direction and F2 in this direction should be equal and opposite. So they are directed opposite and it is equal. So we'll just equate the equation 1 and 2. And so we get, so equating the two equations, the two forces, we get this, where small q would cancel out and capital Q would also cancel out, 4 pi epsilon naught would cancel out, 2 times 2. So what we are left with is 2 upon a square is equal to 1 upon x minus a whole square. So now taking the square root on both the sides, we get x root 2 upon a is equal to 1 upon x minus a, and that would give me on cross multiplication, I'll just cross multiply and get root 2x minus square root 2 times a is equal to a, and therefore we get, on rearranging the terms, that square root 2 times x is equal to, we'll take this on the other side and we get in the brackets 1 plus square root 2 times a. But I want to find out this distance a, therefore keeping a on here right hand side, we can say a is equal to square root 2 upon 1 plus square root 2 times x, and when we solve this we get 0.59 times x. So that means we need to place a charge q at a distance of 0.59 times this distance so that it is in equilibrium. I hope this video was helpful.
Please follow us on Instagram, Facebook and Twitter at tribetopper.com.